right? Like in any language, actually, if you go for any language, any procedural, non-procedural language, there is a background based on which that language has been written or has been formalized, right? It is not like that anyone can write any specific programming language. So to do that, to design a database or any programming language, you need to have a background. Background means there are some things, some operators or some formalisms based on which the different construct or different concept of a programming language is based on. Similarly, in SQL also, because SQL is a programming language, it is a practical programming language actually. There are different concepts based on which this SQL is designed. These SQL concepts has been designed, right? So we are going to start few concepts related to this formal programming language, which is called relational algebra, right? It is actually equivalent to the scenario like before going to design the database, we have drawn the conceptual model of database, which is in the form of ER model. So ER model is a conceptual representation of actual database. Then we have mapped that ER model or conceptual representation in form of ER into the logical representation, right? So then we have created the logical data model, and eventually we have implemented or created the actual entities or actual database tables in the database. So there, while creating the database design, or while creating the database model, the first step was to create the conceptual representation in the form of ER diagram, and after that we have designed its equivalent impression in the form of logical database design. After that, we have actually implemented or practically created the database. So similarly, if you are creating a database and you need to have some kind of programming language to operate with the database, you need to create the programming language also. So SQL is something we are operating with. So to create this SQL concept, these SQL concepts which will be operating on the database, we need some formal background. So relational algebra is equivalent to conceptual modeling. So like in database modeling, when we are designing the database objects or database entities, we have taken ERD as a conceptual representation, conceptual modeling. Similarly, to design a programming language, SQL, we need some formal background. So these relational algebra provides some kind of formal background. So relational algebra is a conceptual modeling, is a conceptual representation of SQL actually, right? So naturally, whenever we talk about a conceptual model or conceptual representation or conceptual language, it will have limited options. It will have limited options, limited features, right? Like in case of ER diagram, we are having only few things like entities, attributes, and relationship and their ratio to represent this whole actual database. But when we go for the mapping of ERD into the logical impression, we have added foreign key aspect also. After that, we have added other things also. When we were creating the actual database by using create statement, we have added its data type, its data size, and all other things also there. Similarly, when we start writing a formal language for SQL, we will have some limited operators. And when we map these formal concepts into the actual SQL language expressions, it will have more operations, more capability, and more functions, right? So let's start discussing this. And these concepts now because we have actually discussed all the functions, all the features of SQL. Looking to the relational algebra will be more convenient to you, right? एक्चुअली में जब होता है अप्रोच ये होता है कि पहले हम स्टूडेंट्स के साथ रिलेशनल अलजेब्रा डिस्कस कर सकते थे, जैसे हमने ईआरडी पहले बनाया फिर उसके बाद उसको मैप किया. सिमिलरली टू गोइंग फॉर अ SQL is better to have first discussion on relational algebra, but it requires lot of assumptions. That's why we have discussed SQL first. Now we are going to discuss, or we are going to review the concepts of relational algebra. So it will be easily relatable now, because we have understood that how different queries can be written for a specific data request, right? So we will try to cover these concepts of relational algebra in today and next lecture. So let me share this class note first, so that it will be convenient to you, right? So now, yes. So let me. So I hope it is visible to you. Now let me zoom it little. Yeah, so right. You can say actually there are two concepts. One is called relational algebra, and there is called relational calculus. So today we are going to discuss the relational algebra, and relational algebra is something which is the first impression. It is the first step to create the formal representation of SQL concepts, right? And relational calculus is basically as next level actually, right? Uh, basically, we are having only few operators because relational algebra is a formal language. It is a formal language or formal conceptual representation of SQL actually, right? You can see because it is having all these equivalent concepts to the SQL. So you should not be confusing with these two concepts. Whenever we are creating SQL, whenever we are creating any programming language on a database, like in our case, we have taken this concept of relational database, right? So relation is there. So similar to the relational database, you can create any model. You can have your own database model. So there you can use your own programming language, which will be equivalent to SQL. So that's why in nowadays we are hearing a lot about NoSQL, right? You can have you can heard about the other version called SQLite. Then we have embedded SQL. So there are different versions of SQL just because we are having different data models, right? So whenever we are having different data models, we will have different modeling concepts. We will have different programming language concepts. That is the responsibility. So it is not like you can have data model without having own data programming language actually, right? So it is a responsibility of database designer, or maybe any person who is trying to design his own data model, right? So whenever we say we are okay, now we are using this concept of database with relational terms. So now we are saying relational database. So we are following we are following this relational database from the last around 15 classes, 15 lectures actually. So relational algebra is something which is having this equivalence or relation with relational database. So whenever we say relational algebra, it means this is algebra. This is the formal language which will be defining or controlling or expressing the operators or concepts related to or to deal with a relational data model, a relational database actually. And that's why we are using this relational term again and again, right? Because we are talking about a programming language, we are talking about a formal language to operate on a relational database, right? So relational algebra is a formal way of or formal representation of SQL. And basically, if it is algebra, it will have some operators, right? So primarily, because we have discussed that we are in the very first step of creating a programming language for the database. When we are in the initial step, we will have limited operations, limited operations to support this, right? So our relational algebra will support only 5 operators. Only 5 operators. You can see this last expression where it is written. The complete set of relational algebra operators are like. These are the 5 operators. These are the 6 operators actually. It is supporting, right? So these are the fundamental set of operators. So by relational algebra says to implement any database query in SQL, to implement any user query in the database request or any database operation, you will have these 6 operators. These 6 operators you will have at your hand to implement any query, right? It is for sure. So other means of this statement is that you can write anything by using these string operators. You do not need to have this set of 20 or 30 operators, right? And that is what relational algebra says. So relational algebra says these are the 6 different operators by which you can write anything. By using these 6, you can create any operator, right? So there are 2 binary operators out of these 6 set actually. These 2 operators are unary. Unary means they will have only one operation, one relational database involved, right? So we will be discussing each operator in next subsequent discussions. Like in unary operators, we have 2 operators, like select operator and project operator. Now you should not be confused with this select operator. Select operator which we are mentioning here, and select operator which we are select clause which we are discussing in the sequel, right? It is so both are having different implications. Along with select, we have project operator. It is again a unary operator. Project operator means you will be projecting on a relation. So there is a relation employee given, suppose, and you want to retrieve the attributes. So you will be projecting on the relational table, like something like that. So projecting means it is to select the attributes. Selecting means you are selecting the tuples, right? Typically, so this is basically overlapping with the concept of sequel. So we will be trying to clarify in the subsequent discussions. Now, in binary operators, we will have these 4 operators like union. Union means either it is a set operator, right? Then we have rename operator. Rename means suppose you want to rename the attribute, or you want to rename the attributes which are retrieved in the result. Next is set difference. Set difference again a set operator. Suppose you want to remove some set of tuples which are common between 2 relations or 2 results. You can do that. Cross product is something which we have discussed as a Cartesian product. So relational algebra says by using these 6 operators you can achieve anything. You can write any expression, right? So with this, we are going next, let's understand how these different operators actually expressed in a query and how they will be having their effect, right? So let's take this first operator, which is select operator. So select operator is what? Basically, it is to select the tuples. So it will be written as by this expression, this, all right? So you can see this operation, this operator, and in the subscript of it, it is the setup condition, selection condition on the tuples, and here R is a relation. So you can see in whenever we are writing a selection or selection condition or selection operator, it will have involve only one single relation, right? So suppose there is a query like you need to retrieve the gender and the salary of the employees. So suppose there is a query, you need to retrieve the detail of gender and salary of all employees, right? It is for project actually. So suppose you want to retrieve, let me write it here again. So I'm pasting here, and suppose there is a let me take as a employee itself. So employee here. Now suppose you want to add condition like d number equals to 4, like this. So you should be writing like this, right? So here we have written the name of relation on which we will be adding this condition. Now this condition will be applied on the tuple actually, tuple. So this is something related to the where clause. So if you can recall, in the sequel we used to write these conditions on tuple in the where clause, right? So this is how you can use the selection condition. Now next operator is basically a project operator. So project operator is something which is used to select the attributes from the result, right? So if I use this expression here, let me copy this and let me type here. Yes. So I hope you can reply to this question. Now, project operators is used as this in this way, right? Here, this is a relation R, and then now as a subscript, you can write the list of attributes. So these are the attributes which will be appearing in the final result, right? So if you see this expression, which we are trying to explain you that this is how. So you can see this inner query will give you the employee details or all details of employees of department number 4. After this, we are applying this project operator on project. We are trying to retrieve gender and salary. So you can simply respond to me that in this query, or by using this query, sir, I am trying to retrieve the details of gender and salary of employee working in D number 04, something like that, right? So this is how we can write a query. by using these two operators at least, selection and projection. So this inner query will give you the detail, all details, all attributes of the department number 4 employees, and this result will be kept in some temporary space or temporary variable. After that, we are applying this project. So this project will be applied on this temporary result, which will have all the attributes. So from all the attributes, we are getting, or we are trying to fetch only gender and salary, right? So now from this, so this is how we can apply project and select in a simple query. Now, if you go for the third operator, which is called rename. So renaming is, as you can say, so you suppose initially this is how we are writing query. So we are getting or we are taking out these three attributes from the employee table, right? Employee relation, and now which is mentioned that we are using pi. Pi is basically project operator. So now out of these 10 attributes, we are only requesting to be presented as first name, last name, and salary. So we are taking out only 3 attributes. Now, if you want to rename it, if you want to rename these 3 attributes, you can write like this. This is the way how you can write a rename operation. So whatever result we are getting, this is kind of assignment operator. So let me highlight it. This is kind of assignment operator. So basically we are sending this right side operation, right side data, whatever right side data, whatever right side portion is retrieved or available, we are basically keeping or assigning into a new relation, right? So this relation will have these attributes with the naming like first name and last name and salary, something like that. So if you write like this, it will rename simply, right? So here R is basically used to rename. That's the simplest way you can say. So this is how rename can be used. Now, next thing is Cartesian product. So Cartesian product is something which we have discussed already. So suppose we have given 2 relations, employee and dependent, and if you basically want to create actually the Cartesian product, you can simply write this: employee cross dependents, right? So this is the operator which can be used to define the Cartesian between these two. So you can remember, I think, whenever we write in from clause, whenever we have 2 relations and we do not add anything on a where conditions, it will automatically create the Cartesian product, right? So here we have assigned or we have stored the Cartesian product of these 2 relations, employee and dependent, into the temporary space which is called temp, right? So this is how we can express at least, right? Now next operation is important, which is called aggregate function. So aggregate function is something which we have discussed in the SQL by using aggregate functions like count, sum, average, min, max, and all those things. So to represent the aggregate function, you can simply use PostScript F. This symbol is called PostScript F. So like you can see in this query, you can see carefully here we are using this count SSN. You can see count SSN average salary, right, on employee. So the inner part will be executed first. So from the employee relation, this count on SSN and average salary, it will be generated. Now group by basically will work on D number, right? This is how it is done. So you can see here aggregate function and group by both are represented. So you can, if you see the innermost part, so from innermost part we are having this employee relation, and in this employee relation we are applying a group by on D number, and after that we are applying aggregate function as count SSN and average salary. So this is the result of inner part. Now we are trying to basically having some kind of renaming or some kind of re-representation by using R function. R, you can say here in the outer part, you can see we are having this R thing. R is basically simple, it is renaming. So renaming into the D number of employees and average salaries. This is how we have renamed the result of internal part or internal query, right? Now let's go to the division operation. So division operation is something which is basically a new operation, or it is having a different kind of importance. So division is something by you can see by this simple example. So here you can see if I want to create a division between these two relations. So there are primarily two relations are given. Like first relation is R with these set of attributes A and B. Now second relation is S with only one attributes, and the values are like A1, A2, and A3. Now suppose due to some requirement, it is required to have the division between relation R and S. So it is like R division S. So this table T is showing the result of division between R and S. So you can see and you can interpret that what is the possible implication of using division operation. So let's take 5 seconds time for 10 seconds to respond to this question. So what do you think how division operation is a division operator is operating? So T is the result here. R is the first table, S is the second table, right? R is the first table, S is the second table. Now between R and S, attribute A is common, right? Because it is important to see the common attribute, because this is the attribute which will be playing a role to identify the resulting attributes or resulting tuples. So T is the result, and we are trying to achieve R division S. So can you tell me what is the possible implication of division operator? So let's take 2 minutes. Let's take a few seconds. You can respond to the chat box. R division S. Right. So what is the way of operation of division operator? Yeah, you need to reply to this query, that how this division operation is operating. Right. I think it is very easy. So it is showing all values of records B which are in A in S. Yeah. So naturally it is having all so whenever we have this query of user, now you can I think relate it. So in SQL also we have a few queries like okay, can you tell me the list of projects where all employees are working, something like that. Can you tell me the list of projects which is working, which is located in all locations, something like that. So these kind of queries will be written in relational algebra by using division operator, right? Similarly, let's go to the next thing. You can keep posting your replies, right? So we will have different interpretation of impression also. Now I'm going to discuss this next operator, which is called join. So join is something which we have discussed in details in SQL, because in SQL we have defined broadly 3 types of joins: inner join, outer join, and semi join. And within each we have taken at least three. So for inner join we have 3, like natural, equi, and theta. And for outer join we have again taken 3, left, out, and full outer join, right? So in relational algebra we do not have these types. So relational algebra will say that we have one join operator, right? Because relational algebra is a formal language. So in formal language we could not have these variations of any operator. But in case of so when we map this formal language into the practical language, like in the form of SQL, we can create the versions of operator, right? So how Cartesian product can be used, how join can be modified and make it to the 3 different form. So here you can see this operator is used to indicate the join operation. So you can see this expression example, we are simply trying to define a join between employee and department. Now you need to mention the join condition. You can see here we have mentioned the join condition between department and employee. So join condition is what? MGRSSN equals to SSN. So this is this attribute is something which is common, or which is shared by these two, which is acting as a foreign key between these two relations. So you can write this department join, then join condition, then second relation, which is employee, right? So I hope you are clear with this concept, that if you change the sequence of attributes, the sequence of a relation, like if you write this employee join MGRSSN equals to SSN and department, so result will be same actually, right? Okay, now we are going to the next or last probably part, which is called set operators. Set operators are basically like union. We have discussed this is how union basically works. Then we have taken set intersection, right? So intersection is there. Then we have set difference, which is referred as a minus and except. So except is something which we have mapped in the SQL also as it is. Let me show you this typical relation, and you can tell me what is the operator which we are using in particular. So here A and student and instructor. So A is basically showing you the base database tables, base tables of base relation. So student is the first relation, and we have given instructor, right? So in student we are having first name and last name of students naturally. In instructor we are having first name and last name of instructor obviously. Now can you tell me what is the result of B? So what out of these three operators, what is the which operator we are using to get the result of B? You can see carefully B, the results of B. Now can you tell me what is the result of B? Which operation we are using? Union, yeah, that's obviously also we can see, because we are having more number of tuples here, right? So and what about C? Now you can see between student and instructor, what is the operator which can be used to get the result of C? C is for intersection, yeah. So that's obvious and that's simple to understand. Now what about D? So D is basically student minus instructor, right? It is the difference between these two, the student and instructor. And E is basically instructor minus student. So this is how you can see. So in some operator, whenever we have binary operator, particularly in some case, some operator, when we change this sequence of attributes, sequence of relations, the result will be different. And in some operator, it will not any impact. Like in case of union, if you perform union between two relations, if you interchange the sequence or appearance of the relations, it will not have the different results. But in case of difference, it will have the impact. So I hope you are aware of the property, this property. So whenever we are having this binary operator, and suppose you want to change the sequence of operands, if this operation of changing the operands will have impact, it means which property of the operator, associative or commutative, loaded like this, right? So whenever we use these, so that's why these properties are important. So whenever we are designing a practical language for a formal language, you should be very careful about these property of operator, right? So now we have almost done with these operators. So these examples, these pictures are taken from a reference book of database by Navathe, right? So you can go, you can refer that book and you can understand the basic concepts of relational algebra, right? I cannot say that relational algebra is equivalent or important as same as the SQL, but it is the first impression of programming language on the database, right? Though in the lectures we have taken in the second, we have taken after the SQL, but usually it should be taught before these SQL concepts, right? Now I'm going to take this is the whole picture. I mean, here you can read carefully, all the expressions are listed. So this snapshot is taken from the Navathe book itself. So this is basically summarizing all the operators which we have discussed. We have discussed select, project, theta join is there. Yeah, so equijoin is also there. So this is how you can. So Deep asked a question that how to write the condition and how to mention that this particular is a equijoin or natural join. So this is how you can write. So for theta join, you need to mention the condition, join condition on the below of on the subscript of a join operator. Similarly for equijoin, you can produce like this, right? So there is apparently no difference between these things, between equijoin and theta join. Natural join, for natural join, you need to write star. Star is something which indicates that star means all. So you need to compare the all common attributes. For union, it is the simple union operator or union symbol. For intersection, it is the again intersection symbol. For difference, you can simply use minus term or minus expression to indicate it. For Cartesian product, you can use cross. For division, you can write the division operation. So these are the list of operators which we can use whenever we want to express a query, express a user query in the relational algebra. Right now, let's take a few examples or few concepts or few expressions to understand that what could be the possible output. Now, one thing is very clear that we can write. So there are two ways of writing a relational algebra expression. So suppose there is a query given to you. Now you have to write the algebraic expression of that particular query. So you will have, or you can have, two ways of writing it. First way of writing it is the first snapshot. You can see this one. So here you can see in the first expression, we have written, or it is written that each and every result, I mean, because to perform a query or to conduct a query, there will be different stages. There will be different intermediate results, right? So the first approach of writing a relational algebra expression is to write each and every intermediate step in one step and assign the result of that step into some temporary variable or temporary table or maybe temporary expression, right? Like, so you can see here. So this is the typical query for. So we will be discussing this query. So we can do one thing. We can first try to understand what is the result of it. So can you tell me what is the result of this? So these both expressions are indicating to a same query, same user query. So you can see the below expression, which is actually precisely written. It is a simple. So innermost part will be executed first. So innermost part will be generating the join between employee and department by using d number equals to d number condition. So it is a equi-join between department and employee. So this result will be used now. It will be kept in some temporary storage or temporary variable. Now on this result, we will be applying this condition of selection d name equals to research. So basically now we are adding this condition on tuples, right? So the join of department and employee will be now filtered for this condition where d name equals to research. So all the tuples which is having d name as a department name as a research will be selected. So we have now result 2, which is temporary 2 or something, anything you can give any name actually. So here we have temp 2. So temp 2 says all the tuples, so detail of all the attributes of join between department and employee, and tuples will have, so tuples will be qualifying where we have d name as a research. Now we have this as a temp 2. Now on this temp 2, we will be applying first name, last name, address as a project. So out of these all list of attributes, right, only three attributes will be selected. So basically, can you tell me what is the possible query, possible output? Audio clear? I don't know. Okay, so we will take all the issues. So can you tell me what is the possible output of this query? Query which is visible to you, expression which is visible to you now. Finally, because we have taken out these intermediate steps. So can you tell me what is the output of this expression? So I'm waiting for your response. So let me know what is the possible output of this expression. Expression which is visible to you. So these are the two alternative expressions. I'm waiting for your response. So let's take 5 to 10 seconds. Yes, please go ahead. So it will have typically the first name, last name of employees who are working on a department named as a research, right? That's simple. So this is one expression. I mean, this is called inline or single line expression here. So there's an equivalent expression for it. So let me drag it here. Yeah. Yeah. So let me mark this, which is something you can say. Yeah. So this is the base expression which we have discussed. Now, if you want to write the same expression, algebraic expression for the same query. So let me type first name is working. Okay, I'm taking out the Niti's reply here, and let me post here. So first name, last name, address of employees who are working in the research department. This is how Niti has written. So I'm taking out her reply and I paste it here. Just paste it in the copy. Let me make it 12 so that it is easily visible to you. First name. Okay. So this is how you can write. So the alternative approach is you can write this expression. So here we are simply doing what? We are simply copying each and every step or each and every intermediate step of the expression in a different step. So it's like in the very first step, you can simply take out the D name, right? You can take out all the tuples from the department where which a D name is research, right? So one or two tuple will be selected from the departments, and all the tuples which will have D name as a research value will be selected, and all the attributes will be selected because we have not applied anything on the project. So the result of first condition or result of first step will be kept into research department. So now it is a research department. Research underscore department is a one temporary storage, one temporary variable which we have created, where we are keeping all these tuples, all these attributes. Now in the second step, you can see we have applied the same join condition between employee table, which is a base table, and this is a temporary table which we have just created in the previous step. So research department. So now we are creating, or we are trying to have equi-join between a research department and employee. So the outcome of this join operation under condition D number is equal to D number will be kept into the research employee. Now, research employee is a temporary 2. It is kind of temporary 2 storage. So we have kept this result of joining between research department and employee table. So we will have all the attributes and tuples which are qualifying these join conditions. Right? Again, we have not added any condition on projection on the attributes. So we will have all the attributes. Now this research underscore EMPS, which is temporary 2, is now used to get the final result actually. So here you can see this projection operator pi, first name, last name, address. These are the things which will be required in the final results are now imposed through pi operator. So these pi projection operator is used or applied on the research underscore EMPS, which is temp2. So now you can see, so after that we will have results naturally. So this is something which we'll be pushing to the user. So you can see each and every intermediate or internal step is represented in a separate space. So by this you can have a better idea about a query, that how this query or this expression will be executed, or this is how it will be evaluating the results on the different steps, right? So basically the relational algebra is basically provides you a better or maybe the elaborated way of understanding the query. Right, so we have this another query. So this is simply written like by this you are simply creating the. So can you tell me the reply? Can you tell me the answer for this query expression? What is the possible query for this? Can you tell me? For this, we have used this PostScript F operator, which is for aggregate thing and group by. So can you tell me the reply for that? Yeah, I'm waiting for your response. So can you tell me what is the possible answer or possible query for this expression? Just go ahead, please. This expression I'm asking about. So we have used aggregate function and group by. So this is something we have just taken 10 minutes back. We have discussed this word. So I'm waiting for your replies. Still no replies. Okay, now I'm going back to the, so you can post your replies. So now after this, so it is simply having this usage of aggregate function and group by. So you can see whenever we use PostScript, right? So to write off this PostScript from my side actually, so here we have used count SSN average salary. So PostScript is having usage of two natures. First is aggregate function, and PostScript is also used to mention the group by clause also. So you can say here, you can see here to PostScript, so to write out the PostScript operator, we have mentioned count SSN, right, and then average salary. So count or SSN and average salary. So these both operators are aggregate functions, right? So it is a set of, it is coming from the aggregate functions. So you can see that in the right side of the PostScript, whatever we write, it is the aggregate function, right? And left of the PostScript F operator, it is the aggregate, it is the group by function. It is the space where we will be using we will be using or adding a attribute name which will be used as a group by function. So you can say by this expression we are writing or we are deriving simply the number of employees working on the department and their salary for each department, right? So you can see, so let me see if any, so no responses has been posted by you. So let me write here. So it will be like for each department, that's just me, each department, the number of employees and average, yes, come on, yes, AVE, average salary. That's what we are getting, right? So by this simple expression, we are getting these outcomes, right? So similarly, let me take you to the next third expression. So now you can go with this. This is a single line expression. So now can you try this query? So it is having primarily, you can, if you can see this first line in this expression in the first row. So things which are mentioned in the first row are having this one single relation, and it is joined with so this is joined with the department thing, and it is again joined with employee thing. So right, can you tell me the outcome finally, because this is probably the last thing which we are discussing for today. So let's try, let's take a few minutes. Yes, we can try. So you need to see, so whenever we have this kind of expression, you need to see the innermost part, right? So here you can see the innermost part is a condition on the project table, where P location equals to Stanford, right? So from this innermost expression, all the projects which is having this Stanford as a location will be selected. That's one thing. After that, we are extracting what? We are extracting this basically you can see after this we are extracting the join between, department and project, right? So we are extracting the join between temporary result, which is having all the tuples, which is having all the attributes along with the tuples with the condition like P location equals to Stanford. So we will be performing join between department and this temporary result, and after that we will be performing a project. So we will be getting the P number attribute, department number, last name, address, and birth date from the actually the join between this temp 2 and employee, right? So there we have 3 steps involved to get the final result. So by this expression you can see, or you can do one thing, you can simply write a step-by-step expression for this query, then you can have the better idea about it. Similarly, if you go for this last query probably, you can see that here we have used this operator called join is there used there, right? Then we have projection, right? So this is again a simple query. So you can see that in the first step we have simply identified all the employees so basically we have taken out all the details of from the employee table, where first name is John and second and last name is Smith. So we have taken all the tuples, all the attributes, all the tuples into the Smith, which is a temporary relation. And in the second step, if you see, we have performed a join between works on and Smith. This condition as ESSN equals to SSN, and out of this result, out of this temp to result, we have taken out project pi pro p number. So we have taken out basically all the project numbers. So similarly, so you can, I hope you have developed some kind of familiarity with these operators and how to express. So we are having two ways of expressing a relational algebra for this, right? So now you can relate each and every SQL query or expression of SQL by using this relational algebra concept. So it is very important. So by keeping the examination in our focus also, it is very important to have idea about the SQL expression for a statement as well as a relational algebra expression, right? Because in examination it will be there that you have to write both. You have to write SQL expression as well as relational algebra expression, right? So with this